So now an example, 5 boys and 5 girls sit at a round table. Now, if you want to, you can draw the table with the 10 seats. It might help you on some of the trickier problems, or just when you're getting going with this topic, it can really help you a lot. Now, there's two types of questions here. One is asking about how many ways they can be arranged, and the other is asking about some probabilities. Make sure you read questions carefully now to see which of these you're doing. One is going to involve a fraction, the number of items in your event space over the number of items in your sample space, whereas many of the questions just asking about the number of arrangements won't require a fraction at all. You'll just need to think of how many ways they can be arranged. So how many ways can these 10 people be arranged without restriction? Well, remember the first person can sit down wherever they like. And now there's 9 people left and 9 chairs. So there are 9 factorial ways that they can be arranged. So 9 factorial, it is a big number, 362, 880. How many ways can they be arranged if the boys and the girls alternate? Well, make a decision about who's going to sit down first. It doesn't really matter. Let's imagine that a boy has sat down first. And if you like, use your diagram there to imagine it. Well, that means that you can now place the rest of the boys or the rest of the girls. It doesn't really matter. If we were to place the rest of the boys, then they're going to be going here, 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 and here in any of those 4 spots. Now, there's 4 factorial ways that you can arrange 4 boys into those 4 positions. And now we need to arrange the girls. There's 5 of them going into 5 positions, so we need to multiply to get all of the possibilities. Now, it wouldn't matter there whether you started by arranging the girls and said it's 5 factorial, multiplied by the arrangement of the rest of the boys, you're still going to get the same answer. And here we've got 2,880 ways that can be done. How many ways can they be arranged if there are 5 couples and they're all seated together? Well, now we've only got 5 items to sit down. So if you treat each couple just as one item, then the first couple can sit anywhere. There's only 4 couples left that we need to seat. So we can do that in 4 factorial ways, imagining that it's just 5 people, not 5 couples. But each couple could be seated this way or that way, and that's going to be a different arrangement. So for every single one of those 5 couples, we need to multiply by 2, because there's 2 ways they can sit down. So we need to multiply by 2 to the power of not 4, but 5, because even that first couple that sat down can do it in 2 ways. So the strategy in that one is arrange the groups and then multiply by the number of ways that each group can be arranged. And there we get 768 different ways. All right, in these questions, we're looking for probabilities. So we've got to find the number of ways that the boys can all sit together. Now, if the boys are sitting together, then the girls are also sitting together by default. How many ways can that happen? Well, there's only one way that can happen, because any one way that's got all the boys on one side and the girls on the other, if you spin it around, it'll look identical. So we can only sit down the groups in one way, but we can arrange the groups a number of different ways. There's 5 positions that the boys could be in, the one on the end next to the girls up this way, all the way down. So it's almost like we're arranging lines now. We've got 5 factorial ways to arrange the boys, times 5 factorial ways to arrange the girls. Now, the total number of ways that we can arrange the 10 people around a circle, we've already considered that, is 9 factorial. No need to put the large numbers into your calculator again, and you can put it into your calculator just like this, and it should pop out nice and simply, 5/126. What's the probability that 4 couples sit together, but Jane and John don't? Now, for a question like this, your diagram is perhaps helpful. Now, who do you sit down first? Well, there's always a choice. You can sit the couples down first if you like, but I would tend to sit down the things that are the exceptions. So let's sit down Jane and John. Now, if Jane goes here, and she can sit anywhere really, there's only one way we can arrange where Jane sits. How many places could John sit in? We've got all the other 4 couples sitting together. So there's going to be a couple here and here. We know that John's not next to Jane. So John can't go here or here, or here or here. Now with a couple here and a couple definitely here, we can see that John could sit here, or, and if he does, then there'll be couples there and there, Or he could sit here, and if he does, there'll be couples there and there. He couldn't sit here because that would leave another person sitting on their own without their partner, and he couldn't sit there, same reason. So there's actually only 1, 2, 3 places that John could sit. So there's 3 ways we can sit John down. Now Jane and John are seated, we can look at how many ways we can arrange the other 4 couples. Well, there's 4 factorial ways we can sit the 4 couples down in the 4 gaps, but each one of them can be arranged 2 different ways. So we have 2 times 2 times 2 times 2, or 2 to the power of 4 ways that the couples could be seated. Now we put that whole thing over 9 factorial, which is the number of ways that the 10 people can sit down, and we've got our probability that will pop out, which is 1/315th. Now there's only one other little thing to note. When you've got arrangements in a circle, if you've got people seated around a table, say, you're not going to flip that table upside down and all the people around it. It sort of doesn't make sense. But some arrangements in a circle can be flipped upside down. So good examples would be a set of keys that you can look at up either way, or perhaps beads arranged around a bracelet. You can look at that bracelet equally from either side. And what this does is it halves the total number of arrangements that there are. So you can work out your number in the usual way and then literally just halve it. And you can see here that if I'm arranging 5 items around a circle like this, then if I flip that circle upside down, then these 2 arrangements, even though when we're looking at people sitting around a table, they look different, if this was a bunch of keys or beads on a bracelet or something like that, these 2 arrangements would, for all intents and purposes, be identical. A word of warning though, if some of those items that you've arranged in the circle are actually identical, then when you flip them upside down, some of the arrangements will be exactly the same upside down and some won't. So that's where that strategy of drawing a diagram or perhaps even writing lists can really come in handy.